Okay, it's me again. It's kind of a crazy weekend here in Brussels with the Pride parade and a lot of other stuff going on. I'm doing this a very short video. I don't want it to last longer than 10 minutes because my previous videos were like, 1 hour and I see people flipping off. I just want to do 10 minutes basically to, thank you guys for such a positive response and discussions that are going on the my previous video where I say there's no such thing as a strong charge, and that got nicely accepted in terms of we agree or we don't agree, but we have a healthy discussion going on, and that's what matters. So in this 10-minute thing, I want to do like, look back at all of the ammunition or the grenades I detonated. The metaphysics of physics. I have two cartoons here, right? One is one I got like, 10 years ago by a very sympathetic Italian researcher. He said like, yeah, this is what you're doing, man. You're a fucking 19th century scientist where you're trying to find an explanation for a phenomenon. And, I just need to get a result that fits into my narrative so I can get my paper into, Nature magazine. The cartoon made me think immediately of, a rather famous encounter of Einstein and Oppenheimer. And I put the picture next to it, and you can Google and you can see what came out of that, and what were the simmering tensions between these two geniuses, I would say. Oppenheimer is a funny character. He also had a meeting with Dirac, which I'm going to quote in a minute. And Dirac challenged Oppenheimer, saying like, I have an equation, the Dirac equation. What do you have? Oppenheimer didn't say much to that. And both sides are right and wrong, I guess, in terms of making things move and trying to understand what we are talking about. What we are talking about is is energy. Energy is something that is carried by matter particles and light particles, by photons, and matter particles, well, we know protons, electrons, and then some kind of hybrid combination of positive and negative charge, like neutrons. The propagation mechanism is just the same. It's sort of a perpetuum mobile mechanism. I'm not going to talk too much about that. The thing I talked about in my previous lecture is sort of, what is a proton? We have this mechanism of an electromagnetic wave where some kind of flux changes in the magnetic field vector, and that will cause, of course, when there is flux, there is circulation. Circulation means that then, and that's the funny thing, is also that because the electric and magnetic field vectors are related, we're going to have some flux of the electric field. And so some flux of the electromagnetic field is then some circulation, of the electric field. And so we have this really funny propagation mechanism, which is kind of hidden by, we can reduce it to into a full factor notation using the D'Alembertian, I'm sorry. But that doesn't add much to the analysis. I fundamentally believe that actually, the vector and scalar potential are the real things in nature, exactly because they sort of get rid of that, pi vector thing between E and B, but let's make it visual. The thing I want to end up with, I said I don't want this to last too long, is in my publications, if you see them, it's sort of, and I get a lot of questions on that, is charge really, non-reducible? So you have an analysis here in terms of charges and fields, and you say that these two entities are not further reducible. Yes, that's what I'm saying. Actually, there's no such thing as a strong charge. There's no such thing as a color charge. When you do sort of a dimensional analysis on Yukawa's proposition for what explains that the two protons would be together in the nucleus, I say, well, you forget about the neutron that inevitably is always there. So there's no such thing as two protons sticking together without a neutron. So you have a 3-body or a 4-body or a 5-body problem. A neutron is a combination of positive and negative charge. And a Platzwechsel model, all the things that, Schroedinger was so unhappy about. Maybe I should point it out. I don't have it ready. But, in higher energy physics, Dirac said basically, higher energy physics, we don't understand it. And in 1958, the very last edition of his Principle of Quantum Mechanics, the very last paragraph of the very last chapter, he wrote, "It's to be hoped for that with increasing knowledge, a way will be eventually found for adapting the high energy theories into a scheme based on equations of motion." And that motion is, in my papers, I work it out, the motion of a photon, the motion of an electron, some kind of structured formula for a proton, what it really is, an oscillated three-dimensional 3D oscillation of charge. So he says basically that, high energy physics or high energy theories should also sort of be based on like these equations of motions of charge or a field. And so then we can unify them in, with low energy physics. I think honestly, this is never gonna work. And it's also where I'm quite kind of humble and say like, positron electron annihilation is still the number one mystery. I call it mystery 103 here, mystery 101, 102, 104, 105. I think I demystified them, but this mystery is still there. How does charge actually vanish? Are the gamma rays that come out of a positron electron annihilation real photons, or do they carry, in a very convoluted way, the way that charge is being distributed over, over an electron as an oscillation? Is there some kind of a relativistic stretching of that charge, or what is going on? Are the photons, the gamma rays that come out of a positron electron annihilation, are they real photons or not? And that's a tough question to answer, and I don't have the answer based on what I read from the publications on that, and the reverse process that's going to be crucially very crucial to establish the Bright-Wheeler process. Can we sort of devise an experiment where we have these, a gamma ray combination, highly energetic gamma rays combining together to create a matter, antimatter, or, to be more precise, a positive and a negative charge together? That's a huge question that is out there, and I will leave it at that. I said this was supposed to be a 10-minute talk. Let's see where I am, and yeah, I am at 10 minutes. I'm not into dogmas, and I really love the engagement here on the YouTube channel. So please do like the videos. Much more importantly, do like the my publications on ResearchGate, where I'm sort of coming in a field that clearly needs some help from outside fields of research, philosophy, economics, systems theory, whatever. But basically, the core science, the king of science, fundamental physics, has a bit of a problem right now, and it's got to do with accepting that at some point in time, you can't fool your way or lie your way around very basic metaphysical or ontological concepts. Force has to act on something. So if you don't have a strong charge or a color charge, you have no dimension for it, then forget about it. If you have that, then you need to do something like Lorentz did, define a structure for that force, the Lorentz force. We have a charge, and then we have a very complicated mathematical geometric structure of how the electromagnetic force interacts with the charge and with fields. And so all this bullshit around wave functions, I'm sorry, I apologize for the term bullshit. I hope this doesn't get censored, but it's a thing, right? You come with a new force, strong charge, color charge, you come with gluons, virtual particles, explain your model. And just, do that, explain your model. Is it a contact force? It's kind of a medieval concept, but I would maybe accept it if you come up with sort of a dimensional analysis and a structure for the new forces you are proposing. The weak force, the strong force, quark gluon theory, etc., etc. I don't think you can do it because, again, I think when you enter the field of high energy physics, you do have situations where basically charge can be reduced to something else. You call it gamma rays. I think these gamma rays that come out of a positron-electron annihilation are not normal photons. They do carry the charge somehow. And that's an intuition, and we need to look at it because it's very much important in terms of thinking about Big Bang theories, where you only have fields, and then somehow charge gets created out of this big highly energetic energy field. Well, if we don't know the mechanism of that, then we don't know much about the origin of the universe. And I will leave it at that. I'm at 15 minutes, and it's been more than enough. I wish you a very great weekend.